Okay, we got the recording going again, and now we're switching gears. We're going on to our 188 scan tool information. And for tonight, we're going to be really focusing on codes. We're going to do, talk about some stuff we talked about a few weeks ago about some of our OBD2 terms, and then we're really going to be focusing on codes. It's my hope at this point, you guys have gotten some type of interface whether you got one from the school or you got one of your own, and you have some way to maybe scan some data from some cars so that, at some point, what I'd like to do is, look at your data and use that for some diagnostics. But tonight we're going to be jumping into codes because usually, pulling codes is where we're going to start, right? So I'm going to change my screen share here to my OBD2 presentation, and we're going to move a few things around to make that all happen. There we go. So we're looking at our diagnostic connector there. I'm going to fix this screen share a little bit, make them a little bit clearer for you guys. We talked last time how with OBD2, we got a standardized connector with 16 pins, and a couple of the big things on this connector are that we have a ground connection here on pins 4 and 5, and then on pin 16, we have power. And from there, it depends on what communication protocol that vehicle has and what pins it's going to populate, okay? But pins 4 and 5 are always going to be ground, and pin 16 is going to be power. So that's going to be universal from car to car. And you could have an issue where your scan tool is not communicating because you don't have a good ground on pin 4 or 5, or maybe you don't have power on pin 16. I've seen that a lot. People start, they put a stereo in the car, they start blowing fuses and doing different things, and all of a sudden we lose power here, and then that ends up leading to a no communication issue, okay? And you might think, well, okay, it doesn't communicate with the scanner, no big deal. Remember, if I have a newer vehicle communicating with the smog machine, which is essentially like a big scanner, that's the difference between passing that smog check inspection and not passing, right, and failing. So all of a sudden with OBD2, we had much more standardization in the way codes were delivered, right? And we had data available on our scan tool. Now, this data that's required is limited, but there could be all kinds of extra data that the car could give us. But we had some big things here that we never had before. One of those is the freeze frame. But I do want to say that the freeze frame, notice it says data available on first code set. So what that means is if my check engine light came on, right, service engine soon, or malfunction indicator lamp, as we would call it with our OBD2 terminology, if that light comes on, one, hey, a code is set. Okay, the computer's mad about something. Okay, we're mad about something at this point. And so if the service engine soon light, the mill, if that light is on, there's got to be a code in the memory there. Okay, so the first thing you're typically going to do with that then is to hook up your scanner and pull those codes. Now, when it comes to those codes, maybe you got 5 different codes. Which code is going to have a freeze frame? Well, if I'm only doing OBD2 generic, the first code to have the first code that was set, if I go back a couple of screens here, just like it says, the first code that is set is the one that gets the freeze frame. So I could set a code for, I don't know, throttle position, and then it sets a code for my catalytic converter and 5 other things. The only one that gets the freeze frame is the very first one that was set. Okay. Now, we've talked a little bit about how, you had your generic scan tools, like essentially our ELM device is a generic scan tool, right? But at the dealer level, manufacturers had their factory scan tools, right? And it was pretty early on where the manufacturers decided, well, you know what? We want to give our dealership techs, we want to give those guys an edge, right? We want them to be able to figure out what's wrong with the car and fix it fast, right? So we wanted to give those guys more data, more information, right? More codes, access to more codes, like the manufacturer specific codes. So for example, I got the GM scanner here. One of the things that GM did that I thought was really cool is they had a system called failure records. They said, hey, this freeze frame deal, that's cool. We like that freeze frame deal. But instead of only having one freeze frame, which is all the government required, was the first code gave you one freeze frame. They said, okay, we're going to give you an additional 5 failure records was their term. And so basically what were the 5 failure records? Well, if you had the GM scan tool, you could, and there could be 5 other codes set, it would basically give you a freeze frame for every one of those other 5 codes. Okay. So it was limited to 5, but man, you had a lot more information. Now, why is that so important? Well, if I've set a code, I want to know, well, what was going on when that code was set, right? Because if the car was at wide open throttle going 100 miles an hour, that's a totally different situation as to the car was on a cold start and it was sitting there idling, right? So the freeze frame is super important for me to know how was the car being operated when the code was set, so that I can reduplicate those conditions to see what was going on, right? So you can get more stuff with a factory scan tool, or if you have an aftermarket tool that can then simulate the factory tool. So like with our little scanner app, we have the ability to have like the free app, or we could have the paid app. The paid app might give us some more factory features and maybe could allow us to access some of those failure records and stuff, right? This slide also talks about, hey, maybe there's manufacturer data on a separate data link connector. And early on with OBD2, manufacturers like BMW and Toyota and a few others did this. They had a separate diagnostic connector under the hood or in other spots where that's where you hooked up the factory tool to get the data. But by the late 90s, early 2000s, I think they figured out, you know what, we don't need to do that. Instead of having to add extra wiring to the car and extra electrical connectors and stuff, a lot of those companies phased out those extra connectors because, hey, it costs money to put those bits on the car. And they said, you know what, we'll just have it talk on different pins of the standard OBD2 connector. And so, yes, some cars had separate data link connectors for the manufacturer specific information, but not too much time, in a few years, that we pretty much moved away from that. Okay, so remember, if the service engine soon or the mill is on, the car set a code, the first thing I'm going to do is go to pull those codes. Like we talked about a few weeks ago, the conditions to set the codes vary, okay? And that gets us to, we'll come back to this deal, but that gets us to, we got the codes, but where I'm getting to is it gets us to this slide, enable criteria, right? Remember that every code that's in that computer system has this specific set of criteria that need to be met before the computer will test for that code, right? So, you know, we said that there's some things that the computer's always supposed to be testing for, like it's always supposed to be looking for a misfire, but there's even situations with that where it's not looking for a misfire, right? One of the easiest examples is if the fuel level looks really low, a lot of times it will turn off misfire monitor. So just in case the person starts running out of gas, they don't get a bunch of false misfire codes, right? It could be that, okay, you have an oxygen sensor code, but you know, it's looking for timed activity. So one of the enable criteria is the engine needs to start with a cold start, and then it needs to see the engine warm up. We call that a warm-up cycle. Maybe that's in the enable criteria, right? So you can't just clear the codes and expect them to instantly reset, because they're only going to be reset when we've driven the car in such a way we meet the enable criteria and the computer tests itself out. When the computer does finally get to test itself, right, when the criteria is met and the computer tests the stuff, that's what we call a trip. Like you've started the car, you've driven it, you ran it, you met the criteria, it ran that monitor, that test, if you will, that diagnostic test, it ran it, and it either passed or it failed, right? Well, what's the difference here, you know, between pass and fail and you know, whether it's a DTC? Well, if it passes the monitor, no check engine light, it's going to record those test results of how well did it pass the test, but everything's fine, everything's happy. If it fails the test, then we go into another set of criteria, if you will. And so with that, I'm going to keep us moving forward. Oop, no, I'll move forward too much. Let's try this again. There we go. And that is, we're going to go to this one here. Okay, let's see. Let me make sure I'm sharing this thing right. There we go. Okay. So all right. It's just some problems don't set the light. Methods to turn off mill might vary. Conditions to set might vary. We start looking at these codes on the screen here, and we divided them up into category. But what's not on here is it depends on what type of code this is. And so what I want to add over here with my text tool is, am I a type A or am I a type B code? Okay, well, what's the difference? Type A, the mill is on first trip. Type B, mill comes on the second consecutive trip. Where it fails. Okay, so this is a big deal. Let's see if I can, I'll squeeze them in here like this. So is it a type A code or a type B code? We don't really know what's programmed in the computer. What I can tell you is that, you know, your fuel codes are usually supposed to be a type A code. A lot of your ignition codes are supposed to be a type A code, in that those problems are considered to impact the vehicle's emissions enough where we want the engine to code up right away. Once we set a code, remember that we turn on the check engine light. Right? We get this service engine soon light on. What we realized in the early days of OBD2 is that, you know what, our customers that buy their, brand new car or whatever, they get pissed off real fast when the check engine light's coming on all the time, right? And so pretty soon the manufacturers realized, oh, you know what? I really want to keep this light off until I'm 100% sure that there's a problem. So in the mid to late 90s, we were doing several reflashes. And of course, it doesn't tell you exactly what the reflash is going to do, the reprogramming of the computer. But my experience with it is a lot of times you reflashed or reprogrammed the computer, and now the damn thing wouldn't set a code to save its life. It could be running around, running on 3 cylinders out of 6, and it didn't want to set a code. And I think it was boiled down to is, hey, they try to keep the customer happy. Keep this light off at all possible, right? So what that means is that a lot of systems moved from being type A codes where they would code up and turn on the check engine light right away to being a type B code. So if I go, well, again, what's the difference between these two? The A turns on the mill on the first trip, turns it on right away. Type B, it's going to take 2 trips, and these need to be consecutive trips. Or let me put it another way, these guys got to be back to back. So I have to have back-to-back trips where I have a failure for the check engine light to come on. And that's where you get a car where, one time the check engine light came on, and then I drove it around, I kept driving it, and then all of a sudden, it turned off. And then maybe it doesn't turn back on for a long, long time, and then finally it turns on again. Well, think how this plays out. For it to run the test, it has to meet the enable criteria, right? So depending upon how you drive it, you might meet the enable criteria on every drive, or you might not, right? So you have that kind of filtering process. Then it has to meet the enable criteria, run that monitor, and it's got to fail, and it's got to fail 2 times in a row, 2 times back to back, right? So if something's just borderline, you have an O2 sensor that's just borderline, that it might take a while for it to finally code up. So what's playing, underneath the scenes is that whole thing of what's going on with the enable criteria. And, is it a type A code or is it a type B code, right? Things like misfires really should be type A codes. But my experience has been, it's not always, maybe it depends on how bad is the misfire, right? Whatever the manufacturer could kind of get away with to try to keep the check engine light off, that was what they were inclined to do. Because if the car's still running good and the check engine light's off, generally speaking, the customer's going to be happy, right? If the stupid light's coming on every other day, the customer's going to be like, this car's a pain in the butt. I'm never buying a Chevy again, or I'm never buying a Toyota, or, my wife told me I was supposed to get a Honda or whatever, right? They're trying to keep that customer happy. So let's relate this to what we would see on our scanner. And to do that, I'm going to change my screen share yet again and see if I can, what I'll do? I will do something else. I will just change it to our desktop here. So I'm going to go to screen, share that. That's going to get a little bit dirty, but it'll work. And I'm going to get this guy out of the way. Now you can see my messy desktop here. But what I'm going to do is I'm going to turn on the document camera, and we'll fire up the phone here. and I'm going to look at my scanner app here. So we got our goat cart there. We'll move him out of the way. We'll get the battery out of the way. This is that car scanner app, which we're using for our class. And you can see my cell phone's been through the war, but hey, the app still works. You can, you know, it'll work even on an older phone, all that type of stuff. So I'm going to go to demo over here. I'll go to last used car, and I'm going to go to diagnostic trouble codes, and it comes up with a really great screen. And this is what I wanted to you know, show you guys is this screen. It's pretty nice, right? So it gives us good definitions. Their codes are known as DTCs, alphanumeric, and then it says, hey man, there's 3 types of codes. There's a stored DTC, right? Means that it's happened several times during the last or several drive cycles. So that means that we've had consecutive trips where that thing has failed, and now it's going to set that code. But it also says, hey, there's a pending DTC, indicating a not confirmed malfunction happened in the current drive cycle. Okay. So remember a minute ago, we were talking about type A or type B. So let's say I have a code and he is a type B code. Okay. So it's a type B code. What would happen is I go out and I start driving the car and I go through one trip, right? What does that mean? That means it's met the enable criteria to run that test. It runs the test and it fails. Okay. So if I do one trip and I fail, but I'm a type B code, I'm not going to turn on the check engine light right away because I want to keep that customer happy. But what I am going to do is I'm going to set a pending DTC. Okay. So on some tools, you have to go to one menu to find the DTCs or the codes. Another, and then you have to go to a completely separate menu to find the pending codes. With this little app, it does them in the same spot. But what I wanted to point out is depending upon what app you're using or depending upon what scanner you're using, these might be located in 2 completely different areas of the tool, okay? And whenever I'm checking codes, I want to check for all my codes or full-fledged DTCs, but I also want to check for all my pending codes as well. The other thing I want to do is I'd really like to check for codes from all the computers on the dang car. So if a car has, I don't know, maybe it's got, you know, a whole network of computers on there, you know, I would like my scan tool to go out and get on the network and talk to every computer on that network and see, okay, you know, do you have any codes? Do you have any codes? Do you have any codes? And check each one. And a lot of times what they'll do is they'll call this a health check, is asking all the computers to see if they have codes. Now, depending upon the car and how many computers are on the stupid car and the speed of your scan tool, it might take several minutes to do a complete health check and pull codes from every computer on the network. But when you do that, you'll have a much better understanding of what's going on with that whole car. Okay. So that's what I would like to do if I had the capability to do so. So we have your regular stored DTCs. We have our pending DTCs, which means it's a B type code. It's failed one trip, but it hasn't failed a second consecutive trip to turn on the check engine light yet. So that's where you could catch a problem that's maybe not turned on the check engine light yet, but it's going to be a problem. Okay. So then what happened in the early 2000s is at some point we decided, well, that's not good enough with those 2 types. So the manufacturers came up with permanent DTCs. Okay. What does that mean? Well, it means it's permanent. You can't erase that stupid thing. What you'd have to do is you'd actually have to drive it a certain way and have it reach enough drive cycles for the computer to clear that code on its own. Okay, you're not going to be able to clear it with your scan tool, is the idea with the permanent DTC. The car has to clear it on its own, which means that it has to do multiple trips, and in some cases multiple drive cycles to clear that code. You know, let's relate this back to the check engine light, right? So I'm gonna erase this stuff, and let's say that, you know, this guy right here, this is my yellow, you know, check engine light, or I'll put mill right here, right? Well, the mill's on. Well, it's on, it's glowing, you know, how could I get the mill to turn off? Well, I could go in with the scanner and I could clear the codes. As long as it's not a permanent code, you know, it'll clear out of there. But even if it is a permanent code, I can take my scan tool and I can try to clear it out, and that should turn off the mill. Well, what if I didn't have a scanner and I wanted the mill to go out? Well, if I did multiple trips, so I do you know, 2 trips in a row, 2 back-to-back trips, where now it's a P for a pass. It passes the monitor. It passes this diagnostic test. If I do multiple trips and it passes, now the car will automatically turn off the mill. So this is where you could get a component that's just starting to fail, right? Like a catalytic converter for efficiency, or an oxygen sensor. And the mill turns on, and you keep driving it, and the mill turns off, and then maybe it stays off for a month, and then it turns back on, right? Because maybe it's just right on that borderline, and it takes a while for it to get 2 trips in a row for it to fail and actually turn the mill on. And then maybe it gets a couple trips where it passes and the mill turns off, and it takes a while for it to reset it. So once you understand some of the ways that they set up the programming of how it was supposed to work, it starts to make sense why, you know, you can have mills that kind of come and then they go and they stay gone for a long time and then they come back, right? So couple things to note on this screen. This is a good advice here. Some ECUs, and it says most, and what I find is the domestics usually allow you to clear the codes while it's running, but a lot of the imports don't allow you to do that, okay? So usually for reading and clearing codes, you're gonna do this key on, engine off, and you might even have to cycle the key a few times when you do this test, okay? When you do that though, you're going to end up clearing some other information. So let me erase a bunch of these scribbles here, and let's see, we're in demo mode. We'll see what we get here when we go to read, and we're going to set automatic and see what it does. Okay, so so what this thing gives us is it gives us a P0301, and it says confirmed. Then it tells a 123 that's pending. Then it's got an inactive code, okay, meaning that that's one that was set, it's sent, then since cleared, it's by itself, but it's still rolling around in the memory, okay? So see this code right here. I told you it's gonna take a couple of trips where it tests the code in a row and it passes its test for it to turn off the mill. That doesn't mean it's gonna erase the code. It's gonna take 40 warm-up cycles to clear that code out of there, okay? So it'd have to see that the engine started cold, it got up to operating temperature, it was shut off. That's a warm-up cycle. it'd have to see 40 of those suckers to clear that code. And if that happened to be like a misfire code or a fuel trim code, it might take up to 80 warm-up cycles to clear out of there. So these codes can roll around in the memory for quite a while. And one of your things you have to do as a tech is you kind of have to prioritize what's the most important code. Some scanners will actually kind of do that for you. And the most important stuff that they think is important, they'll list that stuff first, okay? But for other tools like this one, it's kind of up for us to figure out what it is. So we have this old code rolling around in here, which that could be a false code. It could be something that's been fixed and they just never cleared the code, but that guy's still rolling around. Then this guy has a pending code. So now we know that's a type B code, you know, and it's waiting for this thing to see a failure again before it makes it a full-fledged code. Then we have this P0301 that's a misfire code and it says confirm. So that's a full-fledged DTC. So it's seen multiple failures for that guy. And so he's a full-fledged code turning on the check engine light right now. And then we also have this 1693. And of course, what's different about the 1693 is that's a manufacturer specific code. Okay, so you know, depending upon what tool I have, you know, I might not know what this is. I might have to Google search it for based on the car. If I paid for like the not the free scanner, but the paid scanner, it's then giving me the definition of this code, which is a turbocharger control circuit on a GM Duramax. Okay. Anyways, so that's a manufacturer specific code. Again, it's confirmed on there. But it kind of gave you the difference between, you know, type A codes, type B codes, by you could see what's pending and what's not pending. Now, let's say, well, we've read these codes and we're in demo mode. So demo mode's a little clunky on this, but we're going to go ahead and see what we can do here. We're going to hit clear. Okay. DTC rear codes complete. We'll see now. So this shows you that, uh-oh, we got cats outside that are fighting here or something. This shows you, how, you know, the inaccuracy of this demo, software. So what I'm going to do now is I'm going to switch this thing, exit application. I'm going to close that and I'm going to switch my screen share here to some videos. And let's see if I can get this lined up here. And I want to show you a couple of things that I did here. All right, so we have our vehicle. This happens to be a 96 Suburban. The service engine soon light is on. Okay, this thing's running. You can see it's at 1100 RPM. It's sitting there idling. Service engine soon light's running. So again, the dude in the dash, he's upset. He's set a code for something, right? So our first step is going to be to use our scan tool interface and try to pull that code. Now that ELM tool is the Bluetooth one, if you look at it. And so I'm going to plug him into the dash and I'm going to have to go through some settings on here. And for this activity, I chose to do the non-paid subscription one. I used the free one, and I have to select a different device. So I had to go through and I had to select which device I wanted to communicate. And because I've been playing around with a lot of these different scan tool interfaces, I had to reinitialize stuff and reset stuff up. So let me pause that screen and I'm going to move them forward a little bit. And I had to research for him on the Bluetooth, and I found him on OBD2. So let's see if I can find him. There he is, OBD2. See if I can get it to play again. And once I got him hooked up and I plugged him in underneath the dash to my OBD2 connector, one thing I noticed is that the red light was on. On this tool, the red light tells me that, you know what, I have power on pin 16 and I have ground on pins 4 and 5. So that's good. But the other lights aren't on. So that's not good. And guess what? After multiple times shutting the car off, turning the key on, this guy would not talk to this car, okay? In fact, if you look at the screen, what you'll see at one point is it will say, hey, the cell phone is connected via Bluetooth to the ELM device. So he was talking to the device, but the device was never connected to the car. So the ECU connection, it says disconnected. And I made sure I'd cycled the key on, all that type of stuff. And I've had this problem happen before with some of these inexpensive Bluetooth style 327 devices. Some of the older protocols, like this is a J1850, it just has a glitch and it won't communicate. So then what I did is I switched to a different one. This one had a Wi-Fi connection. So I blew that out of here. I had to select the Wi-Fi one. I had to go through and tell it that it's going to be connecting to Wi-Fi instead of to Bluetooth. So I had to tell that Wi-Fi. I selected that, put in my information, made sure he was talking there. And then it's going to do multiple attempts to start communication. And of course, you got to cycle the key off, cycle it back on, kind of reset stuff. And what you'll notice is now it says it's connected to the ELM. And now it says it's connecting to the ECU in the vehicle. And at some point, it'll say, instead of connecting, you'll see that it says connected. So now we have communication. And when you have communication, what you'll see, if I go down below the dash, well, there's my code. But where is my dash? Let me go back. I must have skipped it. Let's see if I can get it going. Yeah. On this particular tool, what you'll see is that there's a lot more lights being shown on the tool. You'll have a red light, a green light, a blue light will start flashing as it communicates back and forth. So you have a lot more stuff going on there because now it's actually communicating. So not only does it have power on pin 16 and grounds on pins 4 and 5, but now we have some communication. So the lights tell you a lot as to what's going on at that point. So we'll go from there to try to get this thing playing again. Get to where we were. See if I can get it to. I've upset it too much to get it to play, apparently. All right. I'll just pause it and manually move it. So I got it to connect, and then I wanted to start with, hey, I got a check engine light on. I'm going to pull some codes. So click diagnostic trouble codes. Same screen I just showed you guys a minute ago comes up telling me about the different types of codes, right? There's full-fledged codes, there's pending codes, and there's permanent codes. This vehicle's so old, it's not going to have permanent codes, okay? So from there, I say, all right, I want to read those codes. And it reads the codes pretty fast because this thing doesn't have 50 different computers on it. It's only got a few on there. And guess what I get? I get a P0135. There's no pending codes. I have a confirmed O2 sensor code. And it's not just the O2 sensor. Specifically, it's the heater circuit of the oxygen sensor. So H2OS, heated oxygen sensor. It's a bank 1, sensor 1, heater circuit malfunction. Okay. What I could do then at that point is do a little research of, okay, what's the enable criteria? What's going on here? Well, what this truck does is it looks at the oxygen sensor. It might do a quick resistance test of the element that's in there. But the big thing is it's going to look at time to activity. So it starts up cold and it says, okay, well, that O2 sensor should start working maybe after the car's run for, let's say, 60 seconds. The O2 sensor should start generating a signal. And if it doesn't see the O2 sensor generating a signal within 60 seconds, it says, something's wrong. Now, if a couple minutes later, now the O2 sensor starts working, it says, oh, well, the O2 sensor can work, but it took way too long for it to start working. So there must be something wrong with the heater. Okay. That's the kind of the enable criteria is a cold start, like a warm-up cycle is the enable criteria, and it's looking for time for activity. Okay. So with that being said, my next step that I pulled the code, I confirmed what it is. I don't want to just clear it because I'll lose a bunch of information. What I want to do now is I want to check for the freeze frame. When was the code set? Based upon my research, I'm expecting it to be sometime when the engine is cold. So let's do it. We go through here. We say, okay, we're going to get out of here and we are going to select freeze frame right there. Boom. And all this is with the free app at this point. Okay. So now we're in the freeze frame. There's our code that was set. We can see that we were at, just about 15% load. So it's not like we're at wide open throttle. We're just, maybe a little bit of throttle we're giving the engine. Look how cold the engine is. It's still at 64 degrees. So I don't know how cold it was when it started, but it wasn't very well warmed up, right? It hasn't been running very long when it set this code, okay? Fuel trims don't look too bad. So we'll keep going here. So the fuel trims are looking pretty good. We kind of scroll down the screen. What's our RPM? Because the big things I like to see when I'm looking at a freeze frame is I want to see, okay, what's the temperature of the engine? How fast is the engine turning, right? How much is it revved up? How fast is it going down the road? And what's the load? So I can reduplicate those conditions. So I got a cold engine, not a lot of load, 1700 RPM. So I'm just kind of maybe going down, the residential streets, just kind of crawling around. I'm going 21 miles an hour. So not going real fast. So I could reduplicate those conditions if I wanted to very easily, because I have everything laid out for me on the freeze frame. And again, that would line up with what I looked up for enable criteria, right? I got a cold start and I'm doing a little bit of a warm-up cycle here, okay? So all that stuff makes sense as far as, what's the load of the engine, what's the temperature, all that type of stuff. Now, what I want to show you next is where people usually make a mistake. All the time I would see people, they go like, oh, I got a code, the check engine light's on. They'll pull the code and then they'll be like, oh, well, let's, what, I don't want it to have a code. I'm going to clear it out of there. When you clear it out of there, you're also going to clear out a lot of information, okay? So this truck, it's older, so it doesn't have as much info and as many monitors as something more modern, but you will see some stuff change, okay? So here we go. We're going to go through there. We're going to pull that code. We're going to mess around a little bit and look at some stuff. See, these are all the monitors, and you see how all of them, including the one for oxygen sensor heater, says it's completed. That monitor's done. I've tested that system, and whether it passed or it failed, I tested it. That monitor's done, right? Also, we know before that we did have that freeze frame data. Okay, so now, and I'm looking at the freeze frame, I'm going to go through, and I think I got to go to my next video. See, that was number 1. I can't remember. Nope, it's not that one. Oh, there's that guy flashing and communicating. So you saw that. All right. That lets you know she's talking. Okay. So now what I've done here, oops, I messed up my video or something. Now what I've done is I've cleared the code. Okay. And when I clear the code, I'm going to lose a couple things. And it looks like my video clip doesn't have it or something went wrong here. But when you clear the code, not only have you cleared out that code, but now I lost that freeze frame data. Okay. The other thing I lost was my monitors. The guys before that said, hey, we've completed. Well, after you clear the code, guess what? They're not going to say completed anymore. Where is it? See, I'm making it upset because I'm fast forwarding, rewinding so much, but that's the freeze frame. So I'm going to lose freeze frame, and I'm going to lose my monitor status. And so what that means is, you know, if I rolled around for a smog check, all these guys that would say completed, they would now say, they don't say not completed. They usually say ready or something like that, but they won't say completed anymore. And so now it will automatically fail a smog check as well. So generally speaking, where people go wrong is they pull a code, they don't even write anything down, they just clear it. They say, oh, well, let's see if it comes back. Why do people do that? Well, probably because they don't know anything better to do. That was kind of a OBD1 strategy. It was not uncommon on an older car, an OBD1 car. You'd pull the codes and you get like, you know, I don't know, 4 or 5 crazy codes. And, you know, some of the codes were important and you had to deal with them. Some of them were just complete BS. They didn't matter. Maybe they were falsely set because it set one code and then that upset the computer. So it set some other codes because it wasn't really sure what was going on. Okay. So in the OBD1 days, there was no enable criteria and trips and all this stuff that you had to do. So, you know, if you cleared a code, you would see, you know, it would reset usually within a minute. Okay. So you get in there, you pull the codes, you'd write them all down. You'd blow them out of there. You'd clear them out of there by disconnecting the battery or maybe using the scanner or whatever. You'd clear them out of there and you'd run the car. You might drive it around the block or something and see what reset. Okay. And you didn't worry about it. And if some codes were in the memory and then they didn't come back after your short test drive, you figured, okay, well, those codes must be false codes. I didn't have to worry about those. No big deal, right? Well, with OBD2, if you applied that same strategy where you instantly pulled the codes and then cleared them, you lost all kinds of diagnostic information. You lost your freeze frame data. You also reset all the monitors, and that could end up biting you in the long run. So the general idea was to pull the codes, kind of prioritize what's the most important stuff, start with that, go through that flow chart, see if the data that you see supports the code, and kind of go from there. And not until you've done your repair and you're pretty sure about what you're doing and you think like, okay, I fixed the problem, at that point, clear the code. But you didn't clear the codes right away. You generally did your repairs and then cleared the codes because you didn't want to lose that diagnostic data. If you are going to clear the codes, at the very least, write down all the freeze frame data that you have there. And keep in mind, that you're going to end up essentially, losing all these monitors. So the car's really going to have to be driven quite a bit before you're ready to, ready for a smog check or something like that. Okay, so what I would typically do, my typical flow chart to this would be, is I know, like, let's say, we know the code on this truck is for the oxygen sensor. If I can get that thing, where did it go? It's in there, I know it is. Read the codes, there it is. Okay, so we'll erase my scribbles. So we got this P0135, and we determine, okay, yeah, it really is a defective oxygen sensor. So I replaced the O2 sensor, and so I replaced the O2 sensor. I go to clear the codes, right? So I clear them out of there. But before I do that, I take some screenshots of all my data here on the freeze frame, because when I clear the code, I'm going to lose the freeze frame, right? So I make the repair, I clear the code, or I make the repair, I write down the freeze frame, I clear the code. Now I'm going to drive it around. How am I going to drive it around? I'm going to drive it around exactly how it was being driven in this freeze frame. Why am I going to do that? Because I know that met the enable criteria to get it to test this part, in this case, the oxygen sensor, right? So I drive it exactly the same way it was driven in the freeze frame. And then I come back, and now what I'm going to do is I'm going to look for codes again. And would it set a full-fledged code? Well, it won't set a full-fledged code, but you know what it will do? Is it should, if I get there to codes, is it would set, I must be missing it, but it would set a pending code. So what I would do is I'd drive it around like it was being driven in the freeze frame. Then I would go back to pulling the codes, and now I'd be checking for pending codes. Because it's not going to turn on the check engine light right away, because it's likely a type B code, but I'm going to see if I have any pending codes. So if I have a pending code for the oxygen sensor heater, guess what? Boom, my repair didn't work, and I'm hosed. I got to keep digging. But if I drove it around and I met the enable criteria by using the freeze frame data, and I don't have any pending codes, at this point, it's pretty safe to give it back to the customer. When OBD2 first hit the streets, we were freaking out. We thought, man, I'm going to have to do a drive cycle on every car, or, I had guys thinking I got to do 40 warm-up cycles. Like, we didn't quite understand how it was all going to play out. And the concern is we'd have to be driving the car a whole bunch before we gave it back to the customer. And we were certain that we had really fixed the car correctly. Well, once we kind of figured out how OBD2 is put together, and what's the deal with the enable criteria, and how are these things really programmed, what we realized is, okay, well, if we're confident in our repairs, right, all we really have to do is make sure we meet the enable criteria and check for pending codes. If there's no pending codes, odds are, a good 90-95%, we have fixed the problem. Is it 100%? No. If you really wanted to be 100%, you'd put a couple of drive cycles on that car where you met the enable criteria for all the monitors and ran everything. Okay, but it's a fair certainty that you've made a good repair if you at least do a quick drive trip where you meet the enable criteria and check for pending codes. If there's no pending codes, you should be good to go. You are going to have to advise your customer, though, if they're trying to get this thing smogged, they're going to have to drive this car quite a bit, maybe even invite them to come back so you can check the status of all the monitors and make sure all the monitors have ran before they roll over to the smog shop. Okay, so it did add extra layers of complications to what you're doing. Okay, so the big things I wanted to get through tonight is the different types of codes, right? Like we saw, I can get this guy up here on a little scanner screen. It talked about how there's full-fledged codes, there's pending codes, and there's also these permanent DTCs that you'd find on newer cars, that the only way they're cleared from the computer's memory is through an adequate number of, drive cycles and warm-up cycles, okay? So I wanted to make sure that, you guys understood that, and just to point out that, like, hey, whenever you're using a tool, no matter what it is, if there's stuff on the screen or there's stuff in the little manual that comes with it, like, read that stuff, because there's likely some good information there, okay? So 3 types of codes. And then to further divide this out, we talked about how there's a type A, and then there's a type B, and how that comes back and relates to enable criteria and everything else, and how OBD2 works, and why we see people do misdiagnosis. And I think we'll finish tonight with another diagnostic story, okay? And this is one where my boss, back when this truck here was a new truck, this was back in the late 90s, we had several accounts with a lot of the used, our shop had several accounts with a lot of the used car shops in Roseville, down on Riverside Avenue. You still go down there today, and there's all kinds of used car lots. There's Hayes Auto Sales, there's just all kinds of shops, right? Or all kinds of used car lots, I should say, right? Well, one of our main accounts at that time was a high volume used car shop. I think it was Autoville or something like, yeah, I think it was Autoville. And they sent us a lot of business. They were a good account. Well, we had a Chevy truck pretty similar to this guy right here, that was setting codes, okay? But let me change this screen share. We'll go back to the code. Like, I'm setting a P0135 for heated oxygen sensor bank 1 sensor 1, right? Well, I think this thing was set in a code, maybe it was for bank 2 sensor 2, or bank 2 sensor 1, or whatever, right? Basically what happened is, when you look at the way this thing is lined up, if I draw, I'm going to draw just a graphic of the engine, right? Here is the engine, and in blue, here's the exhaust system for one bank. Here's the exhaust system for the other bank. And, each one of these banks, let's say that's a catalytic converter, here's a catalytic converter, and maybe both exhaust pipes end up coming back together right here. Well, as far as O2 sensors, I would have an O2 sensor here, I'd have another one there, I'd have another one here, and another one there, okay? So bank 1 sensor 1, bank 2 sensor 2, bank 2 sensor 1, so I'm going to write a 2-1, this is a 1-1, this is a 1-2 for bank 1 sensor 2, and this would be a bank 2 sensor 2, okay? So see, even when I'm talking about it, it seems like it gets complicated, right? It had a code for one of these sensors, and I can't remember which sensor it was. Let's say it was this one. Well, guess what? My boss pulled the code and instantly just cleared it out of there and said, okay, it needs an oxygen sensor, and he threw the oxygen sensor in it. But he changed this oxygen sensor instead of that oxygen sensor that truly was defective, okay? So he throws an oxygen sensor in it. Unbeknownst to him, he throws it in on the wrong side, but he rips it around Riverside Avenue, and hey, it's not resetting the light, looks pretty good. And he returns the car back to the car lot back to Autoville. So then they have a customer interested in this, I don't know, late 90s Tahoe or whatever it was. They get in the car, and of course, they go on a test drive. And now, guess what? Now it's been another drive cycle, right? Or another trip, I should say, more precisely. Now it's had another trip. Now it went from a type B to a type A, and now it turns on the mill. And of course, the customer sees that. They like, oh, I don't want to buy this truck. And that dealership loses their business. And of course, that dealership is mad at us, right? Because what my boss did is he threw an O2 sensor in there. He ripped it around. He didn't see the check engine light come on. And, I think he even pulled codes, but he didn't check to see if there was any pending codes. And even if he might have checked the pending codes, I don't know if the way he drove it, he actually met the enable criteria to test that thing anyways. So his lack of patience or knowledge for understanding what was going on basically lost our shop a big account because he didn't really adequately verify his repairs. Because he thought, oh, it's just an O2 sensor, I'm gonna slam it in there, I'm good. And he kind of applied what I'll call OBD1 diagnostics to an OBD2 vehicle, and that didn't work. He really had to understand, okay, well, I need to give this thing a couple of trips, or I need to make sure I really meet the enable criteria and check for pending codes. If he had just done that, he would have realized his mistake before he gave it back to the dealership. So anyways, verifying your repairs is a much bigger deal with OBD2 cars because it's just, there's more complexity to how the codes are set and everything. So understanding this of how are codes set, how are they cleared, is really important so that you can make good repairs, and then of course verify that your repairs really did fix the problem before you give the car back to the customer. So tonight's deal was all about codes. Now we know the difference between type A, type B, pending codes versus full-fledged codes versus permanent codes. And we'll get more into that permanent codes thing later. Permanent codes really are kind of a pain in the butt. You can get the check engine light off. You can't get that code out of there until it's gone through a whole bunch of drive cycles or a whole bunch of warm-up cycles. So with that, guys, let me switch this back to my other tools, and we will close that out, and we'll close that out and all that. And I'm going to change my screen share, and we're going to go back to our Canvas page. So I thought, I'd do a few more things, but that's probably a good spot for us to end. Again, with the scanner class, with the 188, I'm trying not to give you a whole bunch of things to do before the meter class kind of winds down. We are getting to the point where some stuff is coming up. So, course waiver, safety test are coming up. And then really, as we get, into April, it's all about, getting the scan tool and getting going. What I would love for you guys to do, right away is get a scan tool if you don't already have one. Start taking some recordings of some of your scan data, and we can look at some of that stuff to build up our diagnostic case studies and maybe do some diagnostics with your vehicles and your data together in class. Like I have some different examples, and we'll get this Chevy here fixed and go through the case study on that. And I have some other things for you, but I think it will be more rewarding for you guys if we use some of your data from your real cars and see how everything's put together. Okay. For this 188 class, so we're not going to have a class meeting next Thursday, but we'll come again and have another lecture the following week. We've been kind of going every other week, so we'll kind of keep on that format. When we come back tonight we beat you up with codes, right? For the first couple sessions, it was all about just like, how does OBD2 work and what was the history and the architecture of this thing, right? And talking about monitors and different things. Tonight's topic was all about codes, right? In our next session, so this will be on, let's put a date on this. So not on the 18th, but when we come back at the end of March on the 25th, what we are going to get into there is we're going to get all into data, looking at the core data parameters of like, well, what are the biggest things to look at? And I'm going to tip you into what I call the big 6 and then the great 8 data parameters to really look at to see what's going on with this vehicle, okay? And then from there, we'll get into you know, more sophisticated things and really get into your case studies. So if you haven't got a scanner, get one. Remember, you can check out a ELM interface from the school. We got several of those guys set up, and I have some that look just like this. I have some of the new VPeak ones. So I have a couple different ones. And what you might want to do if you're checking one out from the school is go to the school, get one, have the scanner app on your phone, and make sure that that thing communicates with your car while you're there. Like, don't leave the school, like pull over in the parking lot, test it out. You might find that you have one like I had in my video tonight where for whatever reason, it doesn't communicate. And then you don't have to drive back to school, just go back to the checkout thing and say, hey, this one's not working. I want to try a different one, okay? Because we have a couple different styles of interfaces at the school. So anyways, try another one. Just make sure it's communicating with your car. And remember, you're going to have to plug in, like, it has to find it via Wi-Fi or via Bluetooth. You have to go in the setup and kind of mess around with that, just like I did on the video, and get it to communicate and before you leave the campus. And then from there, you can start scanning stuff and checking things out. My one word of caution is don't be so busy looking at your scanner as you're driving around that you crash into stuff, okay? So be very careful. Really what you'd want to have is have someone else drive while you look at the scanner. Just, you know, use a great deal of caution when you're doing that. So until our next session, you know, keep learning, keep having fun, pull some data and start saving some information. The nice thing, when it's on your cell phone, it's pretty easy to take screenshots, and you can email me those screenshots so we can start looking at some stuff and put together some case studies that are on your guys' cars, okay? Any other questions tonight? I probably killed you because I know several of you guys were in both of these sections. And so it's been a long night, a long time sitting on Zoom. So I appreciate you guys hanging out with me. Any questions? All right. Well, Lucas, Francisco, Tom, and Alex, thank you so much for being here with me. You guys have a great weekend. I won't see you next week, but I'll see you on the 25th. Okay? All right, guys.
Peace out, Mr. French.
All right. Catch you later.